now we're recording, guys. So again, we have our rate of change. That's one of our main important parts. The other thing is the Y-intercept. We've also called this the start value. This is a very important, the other important main part of a linear function. In a graph, right, this can be seen as the point where the line crosses the y-axis. In a rule, this can be seen as the value of the constant term, or the start value. It's that doesn't have a variable next to it. In a table, this can be seen as the y value where x equals 0. And in a context, this can be seen as a fixed value that gets added to over time. For example, the cost of renting the dunking booth or the base pay for a salesperson. Those would be considered the y-intercepts or the start values. What questions do you have about these two items, the rate of change and the y-intercept? Okay. Can you raise your hand if you need a little bit more time on the screen to write anything down? Okay. I shall pause. So, are you good? Or do you need more time? Okay, yeah. I will wait. Leave your hand up until you are ready. All right, cool. So, now we'll look at some examples. So we have the rate of change and y-intercept on a graph. So looking at graphical representation here. For the rate of change, we have this example here. We've got a line. This is line for y equals 2x plus 1. We said we can find the rate of change. In this case, they're using the letter m for slope by dividing the change in y by the change in x between 2 points. So we've got two examples here. They have this first point here and the second point here. And the change in y was 2. The change in x was 1. And so they did 2 divided by 1. The slope or rate of change is 2. Picking another 2 points, they get the same result. Between the 2 points, there's a change of 2 in y and a change of 1 in x. They're both going positive. And that results in 2 divided by 1. So the slope is 2, or the rate of change is 2. And then they get the 1 because that's where we crossed the y-axis here. And that completes their rule. And when we're looking at a graph to find the rate of change, we pick 2 points, divide the change in y between those 2 points by the change in x between those 2 points. That gives us our rate of change. What questions do you have? Right? And again, the y-intercept can be seen as the point where our line crosses the y-axis. In most of the examples we're going to see, it's going to cross at a nice convenient place where we have a value, like a whole value there. Sometimes it will cross between values. That's okay. We'll figure out how to deal with that later. Again, our y-intercept can be seen as the point that the line that we graphed crosses the y-axis. So this is how we can see the rate of change and y-intercept. Can you raise your hand to show me that you need more time to write anything down? No? Yeah. All right. So now we're looking at rate of change y-intercept. So we just did a graph. Now we're looking at a table. The rate of change on a table, again, can be seen as for every 1 unit change in x, the amount of change in y. Right, so on this table, we go +1 in x, we have a +2 in y, +1 in x, +2 in y. Right, so our rate of change is 2. The rate of change is 2. Right? And then for our y-intercept, again, we look for the value or the pair of points on the table where x equals 0 and what's the value of y. And so in this case, the y-intercept is the point 0, 3. The x value is always listed first. In this case, the x value is 0, y value is 3. Okay. If you do not have a y value where x equals 0 on your table, then you need to get there. You can go backwards in your table, continue on with your table to find it, right? So if this wasn't there, I could use the rate of change to work backwards through my table to get to where x equals 0 and find the y value that goes with it, which we've seen on a couple of previous examples. What questions do you have? So if we use this rate of change and y-intercept from these two tables, right, we end up with the rule y equals 2x plus 3. Right, we have our rate of change here and the y-intercept, and they both go into our rule. So anything I can clarify? Does anyone need more time on this slide? And where do we see the rate of change of y-intercept on a symbolic rule? Right, the slope, again, is the number next to x. or next to our independent variable. We can also call it the slope for the rate of change. And in the general form, or just like, this y equals mx plus b, m represents the slope or the rate of change. It gets replaced with the number once we know what it is. And our y-intercept is represented by b in this form. Again, once we know what that value of y is, it replaces b in the formula. So if we have the rule, we should be able to see these two numbers relatively easy. Any questions on this slide? Good? All right, thank you, that's me. All right. And then rate of change and y-intercept in a context. So this is from a previous problem that we looked at, right, about the dunking booth. So if we're given this sentence, we have the dunking booth cost $150 to rent for the event, and the student council decided to charge students 50 cents per throw. Okay. We see that rate of change as the 50 cents per throw. Right? Again, we see that word per attached to a number, and it's per throw, and we know throws is the thing that I'm keeping track of. The amount of throws is the independent variable. And for the y-intercept, again, we have the same context. We see the y-intercept as the start value of the cost of $150 to rent for the event, right? This, when we put these two things together, again, will give us the rule of, you can say y equals 0.5x minus 150. And our start value is negative because we're looking at a cost, and we charge 50 cents per throw. All right. In the one of the homework assignments, or one of the Google Docs that you guys were to fill in, they asked you to write it in the form of P of T for profit in terms of throws. So you need to use, instead of X, T. And everything else stays the same.